grain, which is the one I shaded in purple, minus the area that I shaded in red. Because the area bounded by the two curves is simply the area below the grain minus the area below the red. So the reason we are saying area below is because number one is about area below. The definite integral within an interval is simply area below the curve within that interval. I mentioned that also last lesson. I said that is the next thing we are trying to do when we're doing definite integral. Okay, that's what it is now. So basically, to find this area is simply to find the area of the curve above minus area of the curve below, depending on what is above and what is below. And of course, you will have different scenarios. You might have something like this. So definitely the curve is the one above. And you might have something like this. Definitely the line is the one above. So it depends on what you have above and what you have below. So the area below the line will be greater than the area below the curve. And this will be the other way around. So that's what we're talking about here. Okay? So then, so far is area on along the x-axis. And you can see that we always use our function, right? And remember, our function is y is equal to f of x. So in your formula booklet, you're going to see area along the x-axis to be integral y dx. Y is the function. But it's different here. Okay? In the last part of the investigation, to be precise, question 5 in your investigation, I asked you guys to investigate the area along y-axis. And you will notice that you tried so many things, the area was not the same until I asked you to make x the subject of the formula, which indirectly is asking you to find the inverse of that function. Okay? Finding the inverse of that function is like reflecting something, right? You are doing a reflection along y is equal to x, if you remember your topic 2. Okay? So you are not talking about this area now, you are talking about the reflection. So that's why we use the reflection of that function, inverse. So the two steps to be taken is to make x the subject, then use integral x dy. Because when you make x the subject, now you get y as a function of y. Sorry, x as a function of y. And that's what you integrate with respect to y within the interval along the y-axis. This interval is along the y. So that's why you're using the function in y with respect to y. Unlike this one, this interval is along the x-axis. This is a function of x with respect to x. It has to make sense in that regard. So that's all. The rest is just everybody practicing. I have not done any example. This is everybody just working on their own. You can watch some of the discussions that came up in the video later. I will encourage you to do so. Yes, ma'am. You want to go out? Okay. No, I didn't collect it. I wanted this to have been like before this class, so it's better understood, rather than splitting area into 2 lessons. Okay? So I'm thinking we look at this question, guys. So again, one important thing that we agreed on is that you have to first get the sketch. You have to first of all get a sketch so you know which of this category you're dealing with. Okay? If you do not have the sketch, then you probably wouldn't know which category you're dealing with. Let's look at this. 12, I asked you to try 12 G and H. H. G and H, right? Okay, it should be easy to do, isn't it? Did you sketch it? Okay. So let's try that together so you guys can continue while I sketch it. So decimals. Everything is on Witcher. So which one do I do? You guys are already doing G, right? Maybe we shouldn't bother about 12. Let's look at 14. No, 13. 13 also is easy because they already have the function already. 13A and B. Let's try 13A together. Page. So these are problems from textbook. Page 599, question 13. Guys, question 13. Clearly, your function is of type 1, right? Everything is above. It's rigid. The only thing is this. Show that this derivative is equal to this. I think that should be easy for you. What does this remind you of? Show that d dx of that is equal to 1 over that. What does this remind you? Should we do that? Should we do it? Okay, let's do it again. We've done that in the last chapter. Okay, we want to show that d dx is equal to, so let's say the function is y, right? Y equals sine x divided by 1 plus cos x. So what do we do first? Krista. You want to show that d dx of that function in the bracket is 1 over 1 plus cos x. Krista, what do you do first? Any of the Kristas can respond. If this was your exam question, where do you begin? Come on, don't waste time. This is past 12 already. This is something I expect you to respond in 3 seconds. What? That's the meaning of d dx. Show that d dx of that function is this. So it's asking us to differentiate. I'm saying, what do we do first? You are repeating what the statement is. Calista, and sit up, please. Say that again. What did she say? Sincerely, I can't hear you.
Make it like sine x times 1 plus cos x to calculate.
Why? We multiply sine x by 1 plus cos x. Is that what you said? Is that what she said? Or maybe I didn't hear that.
He said times 1 plus sine x to negative 1, so you can use the product rule.
Oh, 1 plus sine x times negative 1, why? Why?
So if you can use product rule.
Why? Why do you have to go that length? Can you use quotient rule? Is that a question? Really? Are you saying if this was an exam, you don't know what to do? So to use quotient rule, what's the first thing we need to do? I'm not impressed with this, that we have to struggle with this for 5 minutes. This is last, so does it mean you don't remember vector anymore? You don't remember trig anymore? Seriously. Yes, what do we do after this? What's that? And this? So what do we do after that? What are you trying to do? You want to apply the quotient rule, but what is the first thing you have to do?
Write it out.
Write it out. So what is the quotient rule?
Is v prime
Thank you. See, that's how some of you lose marks, because you don't communicate. You communicate like you're babies. The first thing you're going to tell me is v prime u. What does that even represent? There's no preamble. After all this time, we're still doing this. Yes?
V prime U.
Like this?
Yes.
Minus
Minus
U dv dx.
V
U
squared.
squared.
this is
1 plus cos x.
Cos x.
so there's no need for bracket then. Yes.
Minus
Sin
sin
x.
x.
Times negative sin
Sin
x.
x.
Divided by mhm.
Whole squared.
So this is what?
Cos x
Mhm.
plus cos squared x
Mhm.
plus
Plus
sin
sin squared.
sin squared.
Mhm.
Plus 2
So
cos x
mhm.
plus cos squared x.
So we'll agree with that. Okay, let's move on. Next. So what do I write? Mhm. Divided by
1 plus.
Actually, we shouldn't have expanded. We
Oh.
don't need to expand.
I wonder why he expanded. I thought you mentioned that over and over. Didn't I tell you over and over not to expand the denominator? So, and this is seriously, I'm disappointed that we had to waste time because some people don't know what to do with differentiating this function. So when I give you logarithm, simplify logarithm, it will take some of you 2 minutes to tell me the first thing to do. Logarithm. Just simplify logarithm, not even differentiate. You probably wouldn't remember that. So what have we been doing? Wasting our time? The second part, find the area of the region bounded by this function and that. So, area is equal to what? Integral, and the shape of the function has been given, so you know it's not absolute value form. Yes? 0 to 2, 1 over
1 plus cos x
1 plus cos x
dx.
Yes. And this is, how do we integrate this? Crystal again, any of the crystals, how do we integrate this? This is equal to what? Say that again. Ln 1 plus cos x. When do we use ln?
When the numerator is the derivative.
When the numerator is,
The derivative.
and the derivative of this is non-numerator. Change the derivative to, you mean the numerator? To what? Y. So where would the other sign be? Why do you want, you can't do that. You can only do that if you have what?
Constant.
If you have? I didn't hear you say. Constants. Sin x is not a constant, so you can't move it around. Krista 2. Please speak louder, man. Why? It's all here. That's the reason you were asked to differentiate. You need to be able to make connections. That's the only reason you were asked to differentiate. So that when you integrate, you don't need to waste your time anymore. If the derivative of this function is this, then the integral of this will be this. That's all. So this is simply sine x divided by 1 plus cos x. We did this interval. You need to take this thing seriously. So I believe this is easy to do. We substitute. Oh, there's a problem. Oh yeah, there's no problem. It's radian. Right? We're dealing with radian, so 2 makes sense. Okay? We're not dealing with a number itself. Oh yeah, it's actually the sign that cannot be 2. We can still substitute any number. It doesn't matter. It's radian or degree anyway. So that will be sine 2 over 1 plus cos 2 minus, am I right?
Mm-hmm.
Sine, make sure you're in radian measure, 1 plus cos 0. So whatever this is, it's your result. You substitute and tell us what the final answer is. This is 0, clearly, because sine 0 is 0. So you only need to worry about sine 2 divided by 1 plus cos 2. So what is that? In decimal or fraction?
That's 1.55.
1.55 or 5.6?
56.
5.6 square units. Because it's area, you put square units or unit square. It's 12:15. I guess you have time now. Please practice the questions that have indicated. Unfortunately, we can't do more than this as a class. You should do more on your own. I will not be going into area under the curve anymore. If you have questions while practicing with your friends, please feel free to bring it to class so we can discuss it. If one of the exam questions that I will be sending to you later is giving you issues, feel free to raise it in class, but to avoid wasting time, we will not be going into this. By tomorrow, we'll look at the volume of solid that revolves around this axis. Please go for the next lesson. Thank you.